Okay, we have now started the second of these recordings for workshop number 9 from m1211. And so I am going to go to the whiteboard again, and we have now, following along from what we had for the first one, number C is summation n equals 1 to infinity of -1 to the n plus 1 over n plus 3 over 3n plus 1. Notice that summation n plus 3 over 3n plus 1 is divergent because the limit of the nth term is 1/3. That's not equal to 0, and so we have divergence there. So this series is divergent. The divergence test applies also for series with the minus signs in there. So we are done with that one. And so now D part is this, summation n equals 1 to infinity. And we have -1 to the n over n plus 1 divided by 2n plus 1, all to the nth power. I look at this and I see that the nth power there. So if I strip the minus sign, I still have something to the nth power. That begs the nth root test. So that's what I'm going to use. Nth root test. Fairly straightforward to use in this case. We have the limit as n approaches infinity of an equals the limit as n approaches infinity of n plus 1 over 2n plus 1. And here we have an to the 1 over n. So this is to the nth power to the 1 over n. Notice that we have then something quite simple, limit as n approaches infinity. And we have just n plus 1 over 2n plus 1. That's equal to 1/2. We have to know how to interpret each of these tests. The nth root test says that if this ratio is less than 1, that implies convergence. And since we applied it without the minus signs, therefore this series is absolutely convergent. And we are done. There's D. E. Let's take a look at problem E, summation n equals 0 to infinity -1 to the n plus 1. And this is n plus 3 over 3 to the n. What am I looking at here? I see the n plus 3 over 3 to the n. I see a polynomial divided by a geometric type factor or a geometric series, an exponential. And so if I drop the minus signs, that we will be using the ratio test. But polynomials over geometric factors like to use the ratio test. And so we have an plus 1 over an. That's equal to the limit as n approaches infinity. We have n plus 4 over 3 to the n plus 1 times the reciprocal, 3 to the n on the top, n plus 3 on the bottom. That is the limit as n goes to infinity of n plus 4 over n plus 3 times 1/3. This part here goes to 1. The limit is 1/3. That's less than 1. Therefore, convergent. Therefore, series is absolutely convergent. And we are done. So let me stop that one, and we will leave that, and I will go to the next last problem on the next recording.